Now we will see the conditions of equilibrium for floating and submerged body. Okay, so first we will see the case of a fully submerged body, and imagine a body like this. Okay, so first marking the center of gravity and the force of buoyancy. Suppose the center of gravity is here, and marking the weight W at the in the downward direction, and center of buoyancy B, and marking the force of buoyancy in the upward direction. Okay, so now I have given a small tilt here like this. I have given a small tilt, and now what happens is that this force, okay, so which was acting in the downward and upward direction, now see what happens. See here, this is the weight and this is the force of buoyancy. So when I have given a tilt to this particular side, to this side, there is a formation of a couple. A moment happens which is in the exactly opposite direction. You see here, it is in the opposite direction. Okay, so when I have given a tilt like this, the moment formed by the weight of this body and the buoyant force is in the exact opposite direction. So which will help in coming back, this body to come back to this original position. So this particular case is known as a stable equilibrium. Stable equilibrium. Okay, so the condition is to become the submerged body to become in a stable equilibrium. What is the condition? Condition is this buoyant the center of buoyancy should be above the center of gravity. So that is the condition for the stable equilibrium for the submerged body. Okay, and the second one, unstable equilibrium. So for the unstable equilibrium, what happens here? Suppose the buoyant force is here and center of gravity here, and drawing the corresponding weight and force of buoyancy, that is the forces acting on the center of buoyancy and the center of gravity. Okay, now I have given a tilt. What happens now? The forces are like this, isn't it? Weight here is it in the downward direction, here buoyant force is in the upward direction. So what happens here? The moment formed is in the same direction as that of the tilt. So what happens is, it will the particular body won't come back to its original position. So it is in an unstable equilibrium. So what is the condition for unstable equilibrium? The buoyant force will be below the center of gravity. That is the condition for the unstable equilibrium. So this we have written in this particular words. Okay, so when the weight of the body and buoyant force are same, okay, so same, the center of buoyancy, if it is above center of gravity, this particular body is said to be in stable equilibrium, whereas for unstable equilibrium, B is below G. Okay, so there is one more term known as neutral equilibrium. So at that case, center of buoyancy and center of gravity will coincide at the same point. Okay, next we will see the stability of a floating body. Okay, it is determined from the position of its metacenter. So unlike the case of a submerged body, when we take the case of a floating body, what happens is that you take the center of metacenter. You take the position of the metacenter. That is, when I give a tilt, see, suppose this is the original position of that floating body. When I give a small tilt, what happens? The force of buoyancy got tilted, got shifted to B1 location, and this is force of buoyancy direction, and it meets at the metacentric point, that is a metacenter. And what happens? This particular case, the couple formed by the weight and the force of buoyancy is in the exact opposite direction, which helps to come back to this original position. So this is the case of a stable equilibrium for floating body. So what is the condition? When the metacenter is above the center of gravity, it is the case of stable equilibrium for floating body. You take the second case, unstable equilibrium. What happens in unstable equilibrium? When the metacentric height, suppose the metacentric height is somewhere here. So when I give a tilt, what happens? The weight is in the downward direction, G is here, isn't it? Through the metacenter, force of buoyancy is acting. So see, it passes through force of buoyancy acts through the metacenter, and the couple formed is in the same direction as that of tilt. So it collapses. This particular system is unstable, as an unstable equilibrium. It doesn't regain, come back to its original position. So what is the condition for unstable equilibrium? The metacenter is below the center of gravity. That is the condition for unstable equilibrium. So one more term is there, that is a neutral equilibrium. At that case, G and M will coincide. G and M will coincide. So for the floating body, metacenter determines whether this body is in equilibrium, is in stable equilibrium or not. So these are given in the words. So the stable equilibrium is the metacenter should be above the center of gravity. Unstable equilibrium, metacenter should be below the center of gravity. Neutral equilibrium happens when if the metacenter is at the center of gravity of the body. So it is known as the neutral equilibrium. I hope this is clear to you all. So next one is experimental method for determination of metacenter. So before in the previous video we have found how to find analytically, and this is the experimental method. So consider a body like this. Okay. So there is so the original weight of this floating body be W1. Okay. Capital W. And keep another body W1 over this particular floating body like this initially. See, this is in original, it's in stable form. This is the original position of the body. Now I am displacing this W1 to this location. I am displacing W1 to this particular position. So what happens? This particular body, due to the uneven distribution of the weight, it will tilt. Okay. So it let x be the distance from the axis to the center of the weight W1. Okay. So this theta angle, so it will, since it will tilt, this theta angle can be found out with the help of a protractor and a plumb line. Experimentally we can find out theta. Okay. So how to find out the metacentric height, that is GM. Here this is GM. Okay. So M, I forgot to mark here, this is M. Since this line coincides with this axis, so this is the M. Okay. So this is M. And now how to find out GM here? So for that we will make use of the equation. First we will take the moment caused by the movement of W1. See, since there is a movement, displacement in W1, there is a formation of moment. How to find out moment? W1 into X. Okay, W1 into X. And what is the next one? Due to this tilting, again, below the surface of water, below the free surface of water, what happens? There is a tilt in the center of gravity, G to G1. Because of that, there is a moment. Okay. So, that is W into G into G1. W, this is W into GG1. W in the downward direction into GG1. Capital W. Okay. So, W into GG1. What is GG1? In terms of metacentric height, you can write down this is theta angle and this is GM. Okay, GM tan theta will be GG1. Okay, and you replace it with GM tan theta. Okay, so GG1 is GM tan theta. Now you can equate these two. These two moments should be equal. Okay, so equating those two equations, you will get GM. You take GM only to one part. It will be W1x by capital W tan theta. So this is how you find out GM in that is metacentric height using experimental method. I think this is clear. We will see one example. Here the question is a pontoon of weight so and so kilonewton displaced when it is floating in water. A weight of 245.25 kilonewton is moved to a distance of 8 meters across the deck of the pontoon, which tilt the pontoon through an angle of 4 degrees. So theta is given, x distance is given, W1 is given, capital W is given. Okay. So find the metacentric heights. So direct substitution, all the data are given. See here you can see all the data are given in the question. Directly substitute in this equation. Okay. You directly substitute in this equation, you will get GM as 1.78 meters. I hope this is clear to you all. Thank you.